Hello, this is Mrs. Youd, and today I'm going to teach you Chapter 10, Lesson 3, the Quotient of Powers property. Now, it is incredibly important that you've watched my previous videos about exponents, because I'm going to be using the rules that you should have learned already in this lesson. And if you haven't watched those videos, you will have a more difficult time learning this lesson. So if you haven't watched them yet, please go back and watch those. And you should be taking notes in your spiral notebook while watching this video so that you can use those notes later while you're doing your assignments. So in 10.2 we learned rules 1 through 3. Today we're only going to focus on one rule that we're adding to that group, and that's the quotient of powers property. So let's first look at the numbers. If we had 4 to the power of 5 all divided by 4 to the power of 2, that would be the same as 4 times 4 times 4 times 4 times 4, because we have 5 of them, over 4 times 4 because we have 2 of them. So if we think about dividing out the ones that are the same, 4 divided by 4 is 1, so this cancels to a 1, and this also cancels to a 1. And if we look and see how many we have left, we have 3 of them left. A different way to do that is by taking our two exponents and subtracting them. So then that would give us 4 to the power of 5 minus 2, which is 4 to the power of 3. And you'll notice that when we did the expanded form, we also got 4 to the power of 3 because there were 3 4s left after we simplified the 4 divided by 4, which was 1 a couple of times. So in algebra, if we had a to the power of m divided by a to the power of n, you'll notice that we have the same base here, so we have to have the same base. And then what we would do with the exponents is subtract them. So the answer to this would be a to the power of m minus n. And that is our rule of quotient of powers property. For example 1, we're going to simplify, and again, like the last lesson, we're going to keep our answer as a power. So for this first example, you will not need a calculator to help you find the answers. Okay, so let's just practice that rule first. So you'll notice that in all of these first 4 problems, we have the same base. We have 4.2 in letter A, we have 9 in letter B, -8 in letter C, and x in letter D. So then all we need to do is subtract the exponents, the top one minus the bottom one. Okay, so in letter A, it would be 4.2 to the power of 6 minus 5, which is 4.2 to the power of 1. And anytime you have the power of 1, you actually don't need to write it. So this is actually better just to be written as 4.2 all by itself without to the power of 1. In letter B, we're going to subtract 4 from 7, so that would be 9 to the power of 7 minus 4, which would be 9 to the power of 3. I would like you to pause the video and do letters C and D on your own, and then turn it back on and see how you did. Okay, in letter C, I got -8, all in parentheses to the power of 4, and in letter D, I got x to the power of 5. Okay, let's try these next 4 problems. In letter E, you'll notice that we have 2 to the power of 15, and then on the denominator, I have 2 cubed multiplied by 2 to the power of 5. In our last lesson, we learned that we would add these two exponents here. So then we would have 2 to the power of 15 all over 2 to the power of 3 plus 5. So that would be 2 to the power of 15 all over 2 to the power of 8. Now in today's lesson, we learned that when we have the same base, we can subtract those two exponents. So this would be 2 to the power of 15 minus 8, which would be 2 to the power of 7. So our answer for letter E is 2 to the power of 7. All right, in letter F, we have d to the power of 5 all over d, and remember there's an invisible 1 here. So in this case, I'm going to now subtract these two here, so that would be d to the power of 5 minus 1, And I'm also going to subtract 9 and 8. So that would be d to the power of 9 minus 8. So simplified that, I would get d to the power of 4 and multiplied by d to the power of 1. So in our previous video, we learned that when we have the same base with two exponents like this, we would add those two together. So now my final answer would be d to the power of 4 plus 1, which would be d to the power of 5. I would like for you to try letters G and H on your own and see how you do. Pause the video and then turn it back on and see if you got them correct. All right, in letter G, I got 5 to the power of 8. In letter H, I got negative 1.1 in parentheses to the power of 14. In example 2, we're going to simplify the expression. Notice it does not say to leave it in terms of the power, so that means that you might need a calculator for these next set of questions. So on these questions we have multiple parts to it, and it looks really confusing, but don't worry about it. Just break it down each piece separately and you'll be fine. The trick to these questions is breaking them down and trying to figure out which ones have the same base. So if you look at question A, I see that I have an x here. There are no other x's in this problem. And then I have a base that has 4, and I have 4 to the power of 8 over 4 to the power of 5. So this piece I can simplify. This one I can't simplify. So we're going to leave our x, and then we can simplify this part here by subtracting the exponents. So that would be 4 to the power of 8 minus 5. So that gives me x times 4 to the power of 3. 4 to the power of 3 is 4 times 4 times 4, which is 64. And so we're going to write our answer as 64x. Remember, generally you want to put your variable after the number. So I switched them around, and I'm allowed to do that because multiplication is commutative. On letter B, I have these b's that are the same base, and then I have these that have the same base as 5. So then I would have a to the power of 3, I can't really do anything with that first part, times b to the power of, I can take 4 minus 2, and then 5 to the power of, oh, remember there's an invisible 1 here, we got to remember that, 4 minus 1. So if we simplify that further, I have a to the power of 3 times b to the power of 2 times 5 to the power of 3. 5 to the power of 3 is 5 times 5 times 5, which is 125. So remember, we want to put our numbers first. So I'm going to write the 125 first, and then a to the power of 3, b to the power of 2. I don't need to put the multiplication symbol in between those since they are both variables. All right, in letter C, I can simplify here and I can simplify here. Why don't you finish letter C and see what you get? Turn the video back on and see if you're getting it correct. All right, I got x to the power of 7, y to the power of 6. In letter D, I can combine together these two. See if you can finish that on your own. Turn it back on and see if you got it right. And I got an answer of 81k. You go ahead and do letter E on your own. Turn the video back on and see if you got it right. All right, I got 16x to the power of 4, y squared. And that concludes today's lesson, which is Chapter 10, Lesson 3, Quotient of Powers property.